All right, this one is graphing a line given its equation in slope-intercept form. Let's first talk about what slope-intercept form is. That's going to always be y equals mx plus b. M is your slope and b is your y-intercept. Now, in ALEKS, it has you use a table to find the coordinates needed for this line. Yes, that is one way to do this. You can do this for most any equation. Create a table and then get the points and plot them. Yes, yes, yes. I have a way too down there at the bottom, which I believe is just faster, easier. But I'm going to show you what they're doing with the table to make sure you understand that process as well. So I already have a table drawn here, and notice over here I have my x's, and over here in the center I have the equation, and then over here on the right it's going to show the finished coordinates. So I have the numbers 0, 3, and 6. Why did I choose 0, 3, and 6? Well, I want to look at my slope right here. When I plug a number in for this x, I'm just trying to make my life a little bit easier. I'm trying to make my math a little bit easier. And so I'm going to choose multiples of 3 so that I can easily solve these. So I'm not having funky fractions in the end. So let's just choose my first one at 0. So literally I'm going to substitute 0 in for this x, and I'm going to solve for y. 0 times anything is 0. So this becomes 0 plus 5, which is 5. So my coordinates would be 0, comma 5. All right, let's do the next one, 3. I'm going to plug this number in. So I now have negative 2 thirds times 3 and then plus 5. Well, this is why I chose 3. Look how easy this is. Those 3's cancel, so I'm left with negative 2 plus 5. So my coordinate would be 3, comma 3. Negative 2 plus 5 is 3. All right, let's take a look at the last one. Now I'm going to plug 6 in. So this is negative 2 thirds times 6, and I'll write the plus 5 down here to give myself a little bit of space. 3 goes into 3 one time. 3 goes into 6 two times. So now this is negative 2 times 2, which is negative 4. Negative 4 plus 5 is 1. So this coordinate would be 6, comma 1. Now I take these coordinates over here and I plot them. The first one is 0, 5. So my first point would be up here at 0, 5. Then I have 3, 3. And then I have 6, 1. And then I'm going to draw a straight line and attach those 3. That was pretty good. Okay, so there is actually my line. Now, here's way 2. I believe way 2 is just better. Personal preference. I think it's faster. I just said using the equation, and what that means is it's already in slope-intercept form. Remember I said the m is the slope, which is this number right here, and the b is the y-intercept. That would be this number here. This is my m, this is my b. Watch how cool this is. Step 1 is you plot that y-intercept. Okay, it tells me it intercepts the y at 5. I already have a point there, but I'm just showing you that I can get the exact same answer. The plus 5 means I go up the y 5. Let's say it said minus 5. I would have gone down to the negative 5. See that? Now it says slope. Well, remember, slope is rise over run. Rise over run. So if my slope is a negative 2 thirds, I don't care about that negative just yet. Let me first do my rise. From this point, I'm going to go up 2, 1, 2. From this point, I'm going to go 3. Now, why do I go to the left 3? 1, 2, 3. As you could see, my line was a little bit off there. But why do I go to the left 3? Because it's negative. Go to the left for a negative slope. You go to the right for a positive slope. So as you can see, I actually have the same points. I could also go down 2, 1, 2, and to the right 3, same point. Down 2 to the right 3, same point. So I personally prefer this way 2 method. I just think it's faster. If you like the hands-on approach with a table, that's what Alex is showing you to do. Either will get you the same exact answer.